Welcome to Building for the Future of Android. I'm Dan.
And I'm Ash.
And we're going to talk about the future.
Oh?
But since we did a version of this talk at Google I/O last year, we're also going to reference some of that content and see how things have progressed. Speaking of Google I/O, this talk includes Android 15 stuff we didn't get to at I/O 2024, largely because the features weren't ready when we were preparing and recording the talks. Since there's lots of stuff here, we'll break it up into 3 sections, starting with user experience.
Users prefer apps that draw edge-to-edge.
Yeah, count me in as one of those users.
So, Android 15 enforces edge-to-edge, making the status bar and gesture navigation bar transparent. And 3-button navigation is translucent by default to ensure contrast for accessibility. Edge-to-edge is the future.
Edge-to-edge enforcement also comes with a host of deprecated APIs.
This is an app where edge-to-edge is not enforced. Once edge-to-edge is enforced, the UI hides underneath the status bar, navigation bar, and display cutout.
To be compatible with Android 15, your app will need to handle insets.
Here are some inset handling tips. First, use material components. Many of them automatically handle insets. Second, handle caption bars and display cutout insets. Caption bars are like a status bar for freeform windows. Account for the caption bar and status bar together. These APIs can help move important UI away from display cutouts. Our next tip is specific to views. Use Fit System Windows or Set On Apply Window Insets Listener. Add Fit System Windows to the frame layout and our content avoids the system bars and display cutout. But it's not very flexible because you can't specify which edges to fit. Fit System Windows behavior is also overridden for some layouts to make going edge-to-edge easier. This example has a coordinator layout and an app bar layout and a text view. Edge-to-edge is enforced, but we're not handling insets. Add Fit System Windows equals true to the coordinator layout, and the children avoid the system bars. Then add Fit System Windows equals true to the app bar layout to extend its background into the status bar area, which is the result we want.
That was easy, but unexpected.
Right. Instead of avoiding the system bars, the app bar layout background now draws underneath the system bars due to coordinator layouts and app bar layouts logic for Fit System Windows. Set On Apply Window Insets Listener is generally all you need to handle insets, as it offers more flexibility and is predictable. Tip 4. Set clip to padding to false for recycler views. This app isn't yet edge-to-edge. Target SDK 35, and the navigation bar obscures the last list item. Use Set On Apply Window Insets Listener to ensure the first and last list item are not obscured.
Nice, but now it looks like we have static white bars at the bottom, so this doesn't look edge-to-edge.
Add Android clip to padding equals false. The items scroll underneath the navigation bar, but the last list item is now padded slightly above the navigation bar. For our last tip, investigate the work needed for your app to go edge-to-edge early because it may be significant. If your app needs time to handle insets, you can use this flag. However, it will be removed in the future, so you shouldn't rely on it indefinitely. Instead, use it to migrate one activity at a time. All of these tips and more are available in the blog linked in the description. Also, see these resources to get more guidance on handling insets in Compose and Views.
Moving on to Predictive Back. This feature gives users confidence as they navigate through your app.
An internal Google user study found that this back-to-home animation may prevent users from accidentally leaving an app. But this animation is hidden behind a developer option since Android 13.
In Android 15, say goodbye developer option.
Yeah, so if your app supports Predictive Back, users will see system animations like back-to-home, cross-activity, and cross-task.
Animations are cool. They're the future.
To support Predictive Back, you'll need to migrate. If your app does not intercept back events, you can opt into Predictive Back system animations in the Android manifest. If your app does intercept back events, ensure you're using Backhandler for Compose or on-back press callback for Views.
But it's really easy to accidentally disable system animations with these callbacks.
If you intercept back in your root activity, like your main activity, you'll disable the back to home animation. Avoid intercepting back here. Predictive Back is also supported with Fragment Manager, the navigation component, and with some material components and motions. On the Compose side, Navigation Compose, Shared Element Transitions, and some Material Compose components support Predictive Back. See these resources to learn more. Let's demo Predictive Back. This is Google's Socialite app, which doesn't have Predictive Back animations. I'll add 2 animations, starting with Back to Home. I'll ensure the Android X activity dependency is at least 1.6, which it is. Then, I'll add Android enable onBack invoked callback equals true to the Android manifest. Now the app has the back to home animation. Next, I'll add a custom in-app animation while swiping back from one of the conversations. I'll ensure our navigation compose dependency is at least 2.8 or higher. Then I'll add pop enter and pop exit transitions in the nav host. Now the app has an in-app predictive back animation.
But we can go one small step beyond that by adding a shared element transition. To create a shared element, we need to have a way of keeping track of an animated visibility scope and a shared transition scope. To make it easier to do this, we'll create composition locals to store both of these scopes. Since these values can be null, I'm going to also create a custom modifier inline extension function that can take a lambda block. This will be useful later on. Finally, we'll need to have a way of identifying our shared element. So I'll create a data class that represents different kinds of shared element keys we might want to have. We'll start by adding a shared transition layout around our nav host. Then, we'll initialize the composition local provider with our shared transition layout scope. We'll initialize the composition local provider around our home, and finally around our chat screen. Now we need to let Compose know which composables will be transitioning. So we go to our chat row within contact row and get our shared transition scope from the composition local provider and use with to add it to the context. We mark image as a shared element with this modifier. Since our shared transition scope can, and will, be null, we can use the modifier block to add the modifier conditionally, using our chat shared element key with chat ID as our key. Visibility is handled automatically with the animated visibility scope. The chat app bar has the other shared element, so we add the same transition information. And that's all we have to do to get a simple shared element transition on top of our fade transition. The API also supports shared bounds and more, so you can make really creative transitions. What a wonderful wall of widgets!
These wonderful widgets give users the data and features they want most right from their home screens. Take this widget, for example. Users feel this widget helps them find and connect with their favorite contacts. Get started by designing your widget with canonical widget layouts. Then use Jetpack Glance to develop widgets.
Widgets can update periodically when the app is not awake, for example, once every 30 minutes.
That's often not frequent enough. When your app is awake, however, widgets can update immediately. As a best practice, update the widget while the app is updating, such as from a user interaction. Here's how Socialite Spin on the Favorite Contact widget updates from user interaction. This is the widget. First, let's look at how widgets are wired. In our widget, we rely on Glance App Widget to create remote views. But we don't touch remote views directly. We get to write UI in Kotlin and with Glance composables. We're overriding the provide glance method, which is an excellent spot to fetch our repository. The repository lets us create, read, update, and delete custom widget model instances. The widget model class contains a Boolean if the contact has unread messages. Back in our Socialite app widget, we're passing our repository into our content composable. We load the model for the widget from the repository and display the favorite contact. Our custom favorite contact composable uses Glance composables for the UI. This text composable checks the model to see if we have unread messages. If we do, we display new message. Otherwise, we display no messages.
Now, where do we update the unread messages Boolean?
Our custom widget model repository has a method that updates each widget model with the unread messages boolean, and it also updates the UI. That method is called in two places within the app, when we get a message and when we've read the message. I'm sending a message, and in a few seconds, the widget will update to show me that dog has replied.
People think that the future includes more of this AI stuff. So let's use it to show off a cool glance feature that enables more interactivity in widgets. I'm importing the Google AI Client SDK, which is a useful tool to prototype generative AI experiences on Android. It's just a few lines to create the generative model, selecting the model name, and the API key from my build config. The temperature controls the model randomness. I'm going for very random for unique responses. And I'm keeping the maximum output relatively small. These are chats, after all. To use the model, I create a suspend function, since generate content is also a suspend function, and create a prompt that returns a hello message replete with AI-generated puns, and return our response. In Android Studio, I've added my generative AI data source to my repository, and created a suspend function that sends the animal name into the getHelloAnimal response. Action parameters are passed using keyed maps in Glance. Since I'm going to need the contact ID of the model to get its animal name, over in Socialite app widget, I've created a parameter key for it. I've already created an action callback, which is a handy Glance construct that we can subclass to have Glance call our suspend function. I've already used hilt to get our chat repository singleton. For debugging, I'll output a toast to show what the model generated.
Inside of the favorite contact function signature, we add an onSend AI message action, followed by a button that calls our action onClick. To wire that up, we go back to Socialite app widget and construct our action params, and then call the send AI hello function in chat repository. We have to create the parameters in the Socialite app widget content composable and add our onSend AI message parameter with an action run callback that will call our send AI message.
And with that, Socialite will now send groan-worthy puns to our animal friends from their widgets. Check out this talk from I/O to learn about generative AI use cases in general, and more on how to integrate Gemini Pro into your Android application, as well as this talk to learn about the future of Gemini Nano on device. Let's move on to a bunch of updates you should know about as you plan for the future. Android 15 improves the multitasking experience on large-screen devices by supporting saved app pairs and taskbar pinning. It adds platform support for app archiving, allowing users to install and remove your app while retaining their app data.
It adds PDF rendering improvements that are supported back to 12 through mainline, so you can now add more advanced PDF functionality to your app with a Jetpack library to help simplify integration further. HDR headroom control allows you to tune screens that contain both SDR and HDR content so that the SDR content doesn't look washed out.
Android 15 supports loudness metadata in AAC content so that your users can listen in a variety of environments without having to constantly adjust the volume. And we've added support for dynamic spatial audio over LE audio for improved latency and performance.
On the camera side, Low Light Boost enhances real-time preview and video quality.
And Android 15 adds support to query which camera features can be used together, so you can select the best set for your use case.
Android 15 improves picture-in-picture to help you create smoother transitions.
We keep evolving the way Android apps draw the screen, with canvas support for clipping shaders, as well as 4x4 matrices for transformations and translations in 3 dimensions.
With text, Android 15 improves readability by giving you fine-grained control over line breaks and hyphenation, and other features that make text more elegant and give your designers more options, such as variable font support for Chinese, Japanese, and Korean. One more reason to test your layouts when targeting Android 15.
And to ensure correct font rendering and text-to-speech, Android 15 supports setting the locale for your default resources. Android also improves NFC experiences, supporting one-tap transactions in more instances, makes it easier to build font family instances from a variable font, and supports channel-based notification vibration effects. That was a lot. Moving on to technical quality.
When the device runs out of power, no one's apps can get used. Screen off energy drain is a big problem, especially when the device is using cellular data.
Which is why Work Manager gives you constraints so you can defer background work until the device is charging on lower power Wi-Fi networks, or at least until the battery is no longer low. Last year, I created this super simple flowchart to help you understand how to do background work. And this year, my colleagues made it much more straightforward.
Yeah.
This is what we said last year about running in the background. To help, Android 14 added short foreground services. Android 15 adds a new media processing foreground service type for performing time-consuming media operations.
It's part of our work to evolve foreground services, including Target SDK-gated timeouts for media processing and data sync services, and boot-completed restrictions.
Foreground services provide awesome power, with the requisite awesome responsibility. So make sure to remove unnecessary wake locks, stop the service appropriately, and use lifecycle-aware components for asynchronous work.
You can use Perfetto to record power traces on supported devices. This allows you to examine your use of wake locks, the modem, and foreground services, making sure that the device can suspend properly when your task is done.
Back in Android 14, your app is frozen shortly after it's moved to a cached state. While in Android 15, we're clarifying the behavior of force-stopped apps. They now require user interaction to run again. To help you understand what your app is doing when it starts and reduce unnecessary initialization, Android 15 adds the Application Start Info API. You can add timestamps to instrument your startup and a listener for when startup is complete.
Android 15 also gives you more detail on the storage your app is using, including your installed APK size, DEX opt artifacts, library size, and more.
We've improved SQLite with read-only transactions, row count and ID retrieval without requerying, and support for raw statements.
So more devices can use AV1 more efficiently, we've added opt-in platform support for the David codec from VLC. Updated core libraries align with OpenJDK long-term supported releases, including stricter string argument index validation and changes to language code handling.
The cross-device SDK is still in developer preview, but we're actively using it to launch features such as call casting in Google Meet, as well as Telecom Jetpack. Since last year, we've released the Telecom Jetpack Library Alpha to improve VoIP calling experiences across Android surfaces. And Android 15 includes more to help improve technical quality, such as app-managed profiling and additions to our dynamic performance framework.
Last year, we reminded you of the move to 64-bit only devices, helping to improve performance and reduce the size of the OS, but requiring that all 32-bit apps with C or C++ libraries be compiled and updated to 64-bit. Now, 16-kilobyte memory page sizes are coming to Android, and they will bring a host of performance improvements. But you may have to rebuild or get rebuilt any C or C++ libraries to support these new devices. So make sure you've tested your app.
Android 15 includes Angle for running OpenGLES on top of Vulkan. And you can test out your OpenGLES app with Angle using a developer option. We have no plans to phase out support for OpenGLES, but we expect to only support OpenGLES using Angle in the future.
Finally, Android 15 privacy and security updates. Android 15 adds private space where apps run in a separate user profile, so you'll want to test running your app in a private space. Photo Picker is a great way to reduce your app's access to user data, and it works well with private space, and supports cloud photos with new customization options and search coming soon.
The future has no passwords. To get your app ready for today and tomorrow, Credential Manager aggregates sign in with Google, passkeys, and passwords in one single interface. It now signs in with a single tap, supports autofill to surface saved credentials for relevant input fields. We'll be able to restore credentials to a new or reset device without needing to open apps one by one. It is expanding to support digital credentials, and will be coming to Wear OS 5.
To support transitioning from the Google Fit APIs, we've introduced the Recording API on mobile, which lets you measure steps and soon distance and calories in a power-efficient way. And Health Connect now supports background and history reads, skin temperature, and training plans.
Android 14 prevented apps with a target SDK version less than 23 from being installed. And Android 15 bumps the minimum target SDK version to 24.
Android 15 adds an opt-in flag that blocks apps that don't match the top UID on the stack from launching activities. In addition, the platform supports safer intents in strict mode, adds more changes to secure background activity launches, and adds expanded content URI permission checks.
The Google Play SDK console is a platform for SDK owners to register and manage their SDKs. It gives SDK owners access to usage statistics, anonymized crash and ANR reporting, and allows them to communicate directly with app developers through Play Console and Android Studio. SDK owners can flag SDK versions that have quality or security issues so that app developers know to avoid them. App devs can now share full crash reports with SDK owners directly from Play Console. And in turn, SDK owners can give guidance on how to fix these issues in Play Console as well as in Android Studio. App devs also get email warnings and persistent alerts on the policy status page when using non-policy compliant SDK versions. Until recently, SDK Console was an invite-only product, supporting over 120 widely used SDKs in a few business categories. We've opened SDK Console to any SDK, including open-source SDKs that are distributed from a single verifiable source. So, register your SDKs on SDK Console, and I predict you'll have better insights into your SDK stability and usage in the future.
There's so much more we could cover, but here are some additional predictions.
We'll see more form factors and large screen devices, more users with premium devices, more restrictions designed to improve battery life, a relentless focus on privacy and security, more ways for devices to work together, and of course, lots more AI.
And we're going to keep building libraries, tools, and guides to help you navigate your way into that future.
Thank you for joining us, and here's to the future.